So starting with number 1. Think about your order of operations when you are doing these problems. Parentheses would be first, but you have 2 sets of parentheses. Inside the bigger set of parentheses, you can't really do anything because of the other set of parentheses. So with those, we can't do anything inside, but we can do something with this exponent. Multiply your exponents together. So we have 12 squared, x to the negative 4. All over 6x to the 4th, y to the negative 3rd. Then you have a couple different choices from here. Figure out what 12 squared is, divide that by 6. Flip your negative exponents, start subtracting. That order doesn't really matter as long as they each get done. So let's do this. This would be 144. I'm going to subtract the exponents, so x to the negative 4 minus 4 over 6 y to the negative 3rd. I don't really need to keep putting the parentheses, but I'm going to just because. X to the negative 4 minus 4 would be x to the negative 8. The x and the y was changed places, and we can divide 144 by 6. Someone do that. Tell me what you get. 4. So the 24 is going to stay in your numerator. Y is also going to be in your numerator. X is going to be in your denominator. 24 y to the 3rd all over x to the 8th is your final answer for that one. Do we have any questions on how we got that answered? Anything like that? Yes, to get the 24. Yep. For number 2, we need to simplify this. We have exponents on the outside.
Good morning, Colgan High School. Pardon this interruption and sorry for our delay.
All right, if they come back on, then we end up early. All right, for number 2, we have to apply the exponents to everything. So this is going to be 2 squared, x to the, we're multiplying 6, 3 to the 4th, x to the 4th. Then we would need to figure out what 2 squared is, what 3 to the 4th is, and combine our like bases of x. Since we are multiplying our like bases, we're adding our exponents. Two squared would be 4. If you put this in your calculator, you should get 81. And then multiply 4 and 81 and tell me what you get. Please see. It's not in the pocket. That happens sometimes, but I should have extra batteries in here somewhere. What? Regina? Is that what you got? Great, so 324 x to the 10th is your final answer for that one. Questions on that one? For the last one, this student simplified to get this result. We have to see if they're equivalent or the same. We're going to also simplify it and see if we get the same thing. So from this, we have things inside the parentheses that we can simplify. Divide 30 and 6. We have like bases of x and y, so subtract your exponents. And again, if you are comfortable not writing the subtracting piece and want to go straight into 4 and -1, you can do that. Multiply all of your exponents by 2. Don't forget about the 5 because it does have an exponent of 1. And then figure out what 5 squared is and change your y to the -2, flip it. That's what I'm trying to say. So looking at what they got, we can say those are not equivalent, they're not the same. I think what they did was squared everything first, then combine the exponents. So we see the x to the 8th and the y squared. But somehow they still have y squared up top. Notice.
I think it's -1 for the y because it's
2 minus 3.
2 minus 3 would be 1.
That would be negative.
Oh, okay.
I think that may also be how they got the positive. So actual numbers you divide if they don't have like bases. Okay, other questions on that? Those of you not at your original seats, go back. And then we'll start with, do we have Khan Academy questions first? Yes, with what? The ones from this week?
Yeah.
Okay, you have one specifically in mind. Okay, Regina, one like this. So on the add-ins, subtract, the add-ins, subtract polynomials like this. Okay. I definitely heard the things. Okay, so with something like this, where you are subtracting polynomials, and again, if none of this looks familiar, you didn't watch the videos from Friday, so make sure you do that at some point before next week. It's saying subtract this entire thing from this one, so this is gonna be our starting polynomial. If you wanna write that down, either on your desk, on a blank sheet of paper, somewhere. And we are subtracting the other one. So with each piece, we're looking at 2y squared minus 8y squared, 7y minus negative 5y, 11 minus 7. A positive 7. So for this, you're like combining like terms. The variables, the exponents, those aren't going to change. They're going to stay the same. So 2y squared minus 8y squared will give us negative 6y squared. 7y minus negative 5y. Because it has two negatives. 12y. Positive 12y. 11 minus a positive 7. 4. Positive 4. So your final answer would be negative 2y squared plus 12y plus 4. So I'll put that in because you know. Also don't know if someone answered that correctly already. It's someone here. Got it. Negative 6y squared plus 12y plus 4. So you should still have variables, you should still have exponents, you're not combining everything, just your like terms. Okay. Do we have another specific question from this one before we do the other one? There are adding things in here as well. Subtract from, subtract from, subtract from. These, when it says A minus B, it tells you what A is, it tells you what B is, and it tells you whether you're adding, subtracting, multiplying something, whatever. So do whatever it says. Like here, you would add these two together. So they're really all the same. So let's do one like this. You'll notice that this is similar to when we were doing radical operations and we had two sets of parentheses. That was preparing you for this. Usually it's the other way around because usually we don't do radicals until later, but disregard. So you have a couple different options. I think I talked about this in the video, I don't remember. You can rewrite it so that you have this first term multiplied to everything. And then the second term multiplied to everything, so rewrite it so you understand what that looks like. So the exact same thing we were doing for the radicals when we had two sets of parentheses. Take the first term multiplied to everything in the second set of parentheses, the second term multiplied to everything in the second set of parentheses, and distribute. But you also have to be careful of your exponent rules. Because here we have negative 2 times 9, which would give us negative 18. But h times h, we have like bases that we're multiplying. So we're doing what with the exponents? Adding. So this would be 1 plus 1 to give us 2, not just squared, h squared. But then the next piece would be negative 2h times negative 2, which would give us a positive 4h. 9 times 9h would give us 18, nope, 81. There we go. That's better. H. And then 9 times negative 2 would give us negative 8. And then you have to combine your like terms. What are those? And then
And then 81.
so negative 18h squared plus 85h minus 18. It also needs to be in standard form. So highest exponent to lowest is like everything we've been learning since the beginning of the year are coming together, combining like terms, exponent rules, standard form, all of those things. Distributing, just everything. Questions about that? There's another example in this where they're like colorful boxes. I can't show that because it has like people's names on the sides. But you're doing this exact same thing, multiplying the two things together. If you had a question like this, where it asks you which ones are in, or which, yeah, the which one are in standard form, highest exponent first. That's the office up here. So like down the hallway, you'll see glass windows. Okay. For this one, the ones that are in standard form are highest exponent to lowest. So like A. That one's not, the highest exponent is the first. This one is, so A and B would both work. I don't think it's gonna let me choose. Other specific questions in this, in the exponent roots, I think those were due last week, but questions on that either? And then we're just gonna go through any questions you have in both sets of notes. So let's start with this one. You were supposed to watch the video for this, trying some of these problems. So looking at from 1 to 5, sorry, 1 to 8. Do we have questions on any of those we want to see, go over, it didn't make sense, anything like that? So this is in the multiplying and dividing exponent notes. This would be time if something that makes sense, you're not sure how to start, to ask questions. And sorry, not this 8, but this 8. Yeah. So this is kind of similar to what we were just doing in the quick check. Look on the inside first. Do we have like bases? What do we think? Do we have like bases? Yes. The C and the D, and have numbers we can divide. So actually divide 8 and 4. Subtract your exponents. So not in the review, these are in old notes. In the crate, in the exponents folder. What would be the next step? Linda,
Multiplying it out, the inside exponent with the inside exponent.
correct. So think about that, like distributing the exponent to the other exponents, but multiplying the exponents to the exponents. So 2 to the third, c to the 12th, d to the -6. Let me know if you don't see it. Yes, it'll be right after radicals. So it should be towards the front. 2 to the third is what? 8. C to the 12th stays in the numerator, D to the 6th comes back. So it's not the review, it's old notes. Sophia, did you find it? Okay. Yeah. Sophia, if you don't have that, oh, I do have extras over here. I thought I put them back there. So you can leave that out. Other questions or questions about that? 1 through 7 now. Yeah. Number 5. On the other page. 5 is kind of similar to what we were doing on the quick check 2 / what we just did. What would be our very first step? The 4 to the exponents. We have 3 to the 4, a to the 12, b to the 16, 9, a to the 5th, b to the 8. Then what? Subtract the exponents, you can also figure out what 3 to the 4th is, which from earlier, that was 81. So we have 81, a to the 7th, b to the 7th also, all over 9. And then can we divide 81 and 9? Yes, to get 9. That means we started off as a fraction, but we're not going to end up as a fraction, and that happens sometimes. So 9, a to the 7th, b to the 7th. You still need it. Scroll up. Oh, yeah. Right, other questions, 1 through 7? Yes, 2. And then this guy. Number. Oh, you still need this one? Oh, no. Number 2, you're good. For number 2, what is our first step? distribute the exponents or multiply the exponents to the other exponents. So x to the 6, y to the -4, x to the 15, y to the 12. And then our next step. Add, yes, we have a negative, so in this case, we are adding all of our exponents together. So x to the 21st, y to the. We don't have negative exponents anymore, so we don't need to flip anything. That would just be our final answer. We don't have numbers to multiply or anything, so we don't have to worry about that. Other ones, 1, 3, 4, 6, or 7 from this. Seven. Right, and this is kind of what we were just doing, but now G and H, but that's the same thing. This one has a number though. So same thing, apply your or multiply your exponents to all of your exponents. You need to put in that there's a 1 for 5. So this would be G to the 8th, H to the 12th, 5 to the 1st, G to the 20th, H to the 24th. Make sure this is in standard form, so your number has to go in front. 5 to the 1st is just gonna be 5. Add your exponents. What would your new exponents of G and H be? $28 for G and 36. 5 G to the 28th, H to the 36, Regina.
Is it only one, or
Oh, yeah, you're right, it could be 4, because I didn't multiply. So that's not 5, it's. Figure out what that is, 5 to the 4th. Thank you for catching that. Yeah, I'm thinking something else, because that's 25 squared, which makes sense, because 5 squared is 25, okay. So 625, not 5. Right, any others? 1, 3, I'm losing track of which ones we haven't done yet. 1, 3, 4, 6. Jaden, 6, is that what you're gonna say? Okay, 6 and 3. And then after 3, we're gonna move on. Alright, so we'll start at 6 and then we'll do 3 and then we're gonna go on to the other set of notes if we have time to ask any questions in there. So with 6, same process, multiply all of your exponents together. You have 2 to the 4th, x to the 12th, y to the 8th, 4 squared, x to the 6th, y to the 8th. Whether you start combining your exponents, figure out what these are, move those to the front and figure out what those are, multiply them, that order doesn't matter as long as they're all. So I'm going to move those to the front and add my exponents together. So 12 and 6 would give us 18. 8 and 8 would give us 16. 2 to the 4th would give us 16. And we know this is also 16. What is 16 times 16? 256, Otis. The 256, x to the 18th, y to the 16th. Okay. Questions on that one? We'll do 3 and then get out your other notes if you don't already have them. So this would be, you guys tell me, what would, after you multiply, what would you get? And then the next row, let's move the 4 square to the front and figure out what that is, and then start combining our A's and B's all at the same time.
4 square is 6.
Mhm.
And then it would be A and B.
So if you're not comfortable with skipping all those steps and want to add them individually or multiply them individually, go for it, but you can skip steps. Questions on that one? Right, so find the adding and subtracting. Sorry, adding, subtracting, multiplying polynomials or your polynomial operation notes. If you need those, I do have extras. Say that one more time. So yes and no. I forgot that I did put that on there. Those questions, not all of them are on here. Because there's only 6, so let's do this. If you have questions on these notes that aren't on this one, or vice versa of what I just said, we can go over any of those 10 or any of those 6 at the beginning. So these 6 on the second set of notes, or these 10 on those same notes we were just working on. Some of those are the same, some of them aren't. So any of those. Questions on those? Not the review. So either in the same note, on the same page, 1 through 10, or if you don't have the notes that look like this. Like this at the top, I have extras. I was thinking that it didn't get passed out or something, because I had a lot, so if you don't have this set of notes. Anyone else need this set of notes? Yeah, we're fine. Anyone else need this set of notes? Okay. Anyone else? Did you find it? Okay. So from either page, either the new set of notes, the first 6, even though it shows numbers, or the notes were just on 1 through 10. Questions on any of those? Now would be the time to ask if you are confused about anything. And on which set of notes?
The 1 through 6.
So number 1 on 1 through 6, yes. Kendall, which one were you gonna ask for? Oh, no, okay. That might actually be the exact same problem, not let's see though. Yes, I'm pretty sure. it is. 6, 2, 3, 2, 7, 7. So whether you do number 1 on either set, they're the same. We are adding these polynomials, so that means really you're just combining like terms. Six x plus, sorry, 6x squared plus 2x squared is 8x squared, negative 2x plus 7x. And then, yes. And then 3 minus 7. Negative 4. So anytime you were adding polynomials, you're just combining like terms. Same thing with subtracting, but you just have to be careful. Rewrite it vertically if that helps you better. You can also distribute the negative and rewrite it completely. Right, other questions on the 6 or the 10? Hila? Number 8 on, I think 8 is the same on both, but I'll double check. That is, I think what happened was I pulled some from the other. So number 8, you are multiplying a monomial, a single term, to a binomial, 2 terms. So anytime we have something outside of parentheses, what do we do? Distribute. So that's exactly what we're gonna do here. But your exponent rules are gonna come into play because you have multiple like bases. Multiply the numbers the same. So 2 times 7. X to the 3rd times x, you would be adding those exponents. What would that new exponent become? X to the 4th. And then you're multiplying 2 and negative 3 and just bringing the x to the 3rd. Yeah. Questions about that one before we move on? Otis. We're multiplying like bases. What are we doing with the exponents? Right. So the tricky part here is remembering, when do I multiply? What do I multiply? When do I add? What do I add? Subtract, divide, all of those things. Because it's really easy to mix up. I'm multiplying the bases and then I multiply the exponents, but that's not what you're doing. Right, other questions 1 through 6 or 1 through 10? 6. I think 6 is on here, and I think 6 is the same. So this would be just like a normal distributing problem. 5x. Some of them will be like that. If you don't have x's, you don't have to apply the exponent rules. Other questions 1 through 6 or 1 through 10? Or really 2 through 5, 7, 9, 10. 7. Okay, so same thing, but now we're multiplying a monomial to a trinomial. So we're gonna distribute 3 times. So multiply the numbers like normal, -4 times 1. We're multiplying like bases, we're adding the exponent, so that new exponent would be 4. Multiply the numbers just like normal, negative times a negative is a positive 20. We're multiplying like bases, so our new exponent would be. Jada, x to the third. And then for this last one, we're just multiplying the numbers and bringing the x and the exponent with it. So positive 12 x squared. We know we're done because we can't combine any of those. They're not like terms. It's already in standard form, all of those things. Questions on that or other questions 2 through 5, 9, 10. Dylan, did you have a question? No. Regina? Mhm. I'm going to show you 2 different ways to do this one. You can do it how we did the one on Khan Academy, where you rewrite this as it being vertical. So I kind of just moved it. And then I'm looking at it directly. 3x squared minus 4x squared would give us -1x squared or -x squared, yes. 5x minus -7x. Be careful with that one because it has 2 negatives. Oh, so 12x, because you're adding. And then -6 minus a -9. Be careful. You're close. Positive 3. -x squared plus 12x plus 3 would be our final answer. You could also. And this is gonna be your preference. Take this negative and distribute it. Like we've been kind of doing. And rewrite everything. So I'm gonna write it in a long line. 3x squared plus 5x minus 6 minus 4x squared plus 7x plus 9. And then just combine your like terms in order. You would get the same thing as long as you distribute your negative correctly. So whichever one makes more sense to you, distribute the negative and then combine like terms, or move it so that you're subtracting vertically and then keep the negative in mind, either or. Okay, any other questions? 3 through 5, 9, 10. Multiplying binomials 1 through 6. Do we have questions on any of those, Jaden? 4. And I'm going to show you multiple ways. So I showed you how you could rewrite it. I'm going to show you the other 2 ways. Using FOIL. So using FOIL, we're going to multiply the first things together. So the first would be 3x and 2x. Which would give us what? 6. What about the x's? X squared. The outer term, so that would be outside 3x and positive 1. Which would just give us 3x. The inner terms, so opposite of what we just did. Negative 10 and 2x. Which would give us negative 20x. And then our last terms will be, so first were 3x and 2x, last would be negative 10 and 1. So it's the same process as rewriting it, just a little bit faster. And then combine your lit terms, 3x and negative 20x. We have 6x squared minus 17x minus 10. The next one we do from this section, I'll show you the other method, and then you can choose between these three, rearranging, doing the FOIL, doing this last method. Other questions in 1 through 6 that we want to see go over? Jada?
If we do that, would you have to write out the exact same way and stuff like that?
No, so as you start to get the hang of this, you could just do this. I'm gonna do this for this example. This would be your first. This would be your outer. Your inner, your last. So as long as I see that you have 4 terms and then you combine them to get 3, that's all I need. How you do that is up to you. Right, with that same one, since I kind of did that same method, but not writing out every step. You could also use this box method. I don't know if you guys have talked about Punnett squares yet in science. Some of you, yes, okay. Some of you don't know what I'm talking about, but it's something with like genes or something. I don't remember all the sciencey stuff that goes along with that. But it can be applied here. Doesn't matter where you put whatever. But you would put the terms on top of each box. So 5x plus 2, x minus 4. And then you're going to multiply each set of terms together. So 5x times x will give us 5x squared. 2 times x will give us 2x. 5x times negative 4 would be negative 1x. 2 times negative 4 is negative 8. Same process, just a different way. I would definitely say using the box method will help you when you are multiplying binomials to polynomials, multiple things. I'll show you that here in a second. And then you would have your 4, look for your combining terms or your like terms, and then just rewrite it as your final answer. So whichever method makes more sense to you, use that. Other questions on 1 through 6? Questions on 7 and 8? Here. 8, okay. So 8 we're gonna use, I'm gonna show you both methods. Box method and then how you would rewrite this. So box method is gonna be faster. You're gonna draw a box of 6 instead of 4. Whether you do this horizontal or vertical, doesn't matter. Wherever your 3 is where your 3 terms or more is going to go. And then we'll have negative 3x plus 1 on the side. And then we're gonna multiply each piece to each piece. Negative 3x times 2x squared would be what? Negative 6 to the 3rd power. negative 3x to the times negative 6x. Positive 18x. You have an exponent. Not cubed, squared, yep. And negative 3 times negative 3x. Positive 9x. And then this last column is being multiplied by 1, so all of these are gonna stay the same. Then we look for our like terms, start writing it in standard form. Negative 6x to the third, we don't have another term for that, so we're just gonna write that down. We have two terms that are squared. So we're gonna combine those. 2x squared plus 18x squared would give us 20x squared. We have two sets of x's. 9x minus 6x is a positive 3x. And then our negative 3 at the end does not have a there. So our final answer would be that polynomial, negative 6x to the third plus 20x squared plus 3x minus 3. Using that same problem, I'm going to show you the other method. If you like the box method and are just going to use that, you don't have to write this down. If you wanted to rewrite it, you're going to take the first term and multiply it to everything, whether that's you rearranging or just writing what those are. And then the second term and multiply those to the same thing. Again, you don't have to do it this way. You also don't have to write it. If you want to just multiply it and write what that is, you can do that. So this would be negative 6x squared plus 18x plus 9x cubed squared plus 2x squared minus 6x minus 3. And then you have a bunch of terms you have to combine. So it would be similar. I think that is all. Great. Other questions about multiplying polynomials or binomials or any of those, adding, subtracting? Later.
So when there's a box method, doesn't matter which way you put the numbers.
When you say which way, do you mean if I put this over here or this over here?
Yeah, I mean, like you put the small, 3 on the y-axis instead of the x.
Okay, so try not to think about it like X and Y axis. I could have drawn it vertically for this one. Sure. And did negative 3x plus 1. I could also put this over here. I could also put this down here. That part doesn't matter. It just has to match however many terms you have. Other questions? Let's see. Okay. If you feel like you still don't understand any of that, please come to me after school today or tomorrow morning. Monday, we don't have school. Tuesday would be the next time I see you, and Tuesday, we're taking our quiz. So Tuesday morning would be the last time to come get help. So please come see me if any of this does not make sense. If you do not watch the videos, make sure you also do that because that will help you as well. You have so much practice right now that you could try. Practice in these notes, practice in the review I just gave you. So this page is going to look similar to the original notes because it literally is the same. practice in the other set of notes. So you have tons of practice that you could be using, Khan Academy, these. I will say, if you're working in the review, make sure you pay attention to these problems. They're similar to what we just did, but they have fractions instead. You do the same thing, you'll end up with homework. Okay, so use the next 10 minutes to practice, and then I'll let you grab your phones and things like that.